Hello! This video is about electron orbitals. We've talked about where electrons are in the atom. We've talked about that you can think about electrons as being on different energy levels, level 1, level 2, all the way up to level 7. You can break those energy levels down into subshells, S, P, D, and F. And now we're going to talk about different orbitals that the subshells are made of. So, in the question of where to sleep, right? We've used this analogy before. You get a bunch of friends, we're going to a hotel. So each person is going to take the lowest available floor because nobody wants to climb the stairs. You're going to take the sunny room first because the view is really nice. And you're going to take your own bunk bed before sharing a bed so that we don't disturb each other, the top and bottom people on the bunk bed. So the first person will go in the first floor sunny room, and then we'll share a bunk bed. And then we go in the second floor sunny room, share the bunk bed, and then in the pink room. So each person is going to take their own bunk bed, and then they're going to double up and share. Same thing, third floor, we get 2 people in the sunny room. Each person in the pink room gets their own bed, and then they double up. And we've talked about how this question of where the people are sleeping is like the question of where are electrons, right? You can say that an electron is on the first floor. You can say that an electron is on the second floor in the sunny room. You can say that an electron is on the first bunk bed in the second floor in the pink room, right? So this is our analogy that we can use. Let's learn about the difference between orbits and orbitals. In the Bohr model, when we have energy levels, right, the electrons are in orbit around the nucleus like planets around the sun, and you can say that the electron is here, right? This electron is on energy level 2. That's how we think of them, like planets. But in the quantum mechanical model, which is where orbitals are, the idea is that orbitals represent quantum mechanics, represent really advanced math, and they're regions where the electron is probably located. You can't say with 100% certainty the electron is here. All we can do is describe the shape where there is a 90% chance of finding the electron somewhere in this space. So an orbital is like a probability cloud. Each orbital can hold up to 2 electrons. The different types of orbitals are different shapes, and there are different numbers of orbitals in each subshell. And the sizes are different at different energy levels also. So let's see what that looks like. Here's a quick chart. We have 4 types of orbitals, S, P, D, and F. S orbitals start at level 1. P orbitals start at level 2. So there is no 1p. There's just 1 S, right? D starts at level 3. F starts at level 5. Each subshell contains a different number of orbitals and holds a different number of electrons, but every orbital, no matter which type, holds 2 electrons per orbital. We'll come back to this idea again in a couple minutes. So here's what the orbitals look like. S orbitals are spherical. It's the simplest shape. There is 1 s orbital per level, so there is one 1s orbital and one 2s orbital and one 3s orbital. And they're just different sizes. So 1s is small, 2s is bigger, 3s is even bigger, but the shape is all the same. And each s orbital holds 2 electrons. P orbitals are a little bit more complicated. They kind of look like dumbbells or double teardrops or infinity signs. There are 3 p orbitals in each p subshell, starting at level 2. So there's no 1p, but we have 2p, and there are 3 p orbitals on level 2. That's like saying there are 3 bunk beds in the pink room. Each bunk bed holds 2 people, so the pink room in total can hold 6 electrons. I'm mixing metaphors a little bit, but I hope this helps. In this picture, the 3 p orbitals are colored, so you can see that they're all oriented differently. There's a left-right p orbital, a front-back p orbital, and an up-down p orbital. And when you put them all together, they look like the bottom right picture, so you can see all 3 p orbitals at the same time. You should know what an s orbital looks like and what a p orbital looks like. Here's D and F. You can see that the shapes get very, very complicated. You do not need to be able to identify for sure which type of orbital these are. But the d orbitals, there are 5 of them at each level. D orbitals start at level 3. Each orbital holds 2 electrons, so that's 10 electrons in the d subshell. There are 7 f orbitals, each holds 2, so there are 14 electrons that can sleep in the f subshell. And we can use the periodic table to help us remember this information or figure this out, right? We've talked about the S block, P block, D block, and F block. These are sections of the periodic table where the outermost electrons, the last electrons to go, or where the elements have electrons in that subshell, right? The S block is 2 elements wide, so there are 2 electrons in each S subshell, which means 1 orbital. There is 1 bunk bed in the sunny room, and it can sleep 2 electrons. The P block is 6 elements wide, right? So we know that the P room, the pink room, the P subshell can hold 6 electrons. That means that there are 3 bunk beds, so there are 3 orbitals in the pink room. The D block is 10 electrons, 10 elements wide. That's 5 orbitals, or 5 bunk beds in our analogy. And the F block is 14 elements wide, so there are 14 electrons in the F block, and there are 7 orbitals in the F block room, whatever you want to call that. And we can describe where electrons are using an orbital diagram that looks like this. So we use arrows to describe the arrangement of electrons up or down. This is like the top bunk and the bottom bunk, right? So in the 1S room, the first floor sunny room, that can sleep 2 people, so there are 2 arrows, but 1 electron on the top bunk and 1 electron on the bottom bunk. This refers to a property of electrons called spin. Electrons can have spin up or spin down, but electrons have to have opposite spins when they're in the same orbital. So you need a 1s electron with a spin up and a 1s electron with a spin down. You can't have 2 electrons with the same spin. That's like having both people sleeping on the top bunk and the bottom bunk empty. That doesn't work. You'll also notice that the 2p subshell has 3 orbitals, like 3 bunk beds. The first bunk bed is full, and the second and third bunk beds, the second and third orbitals, only have 1 electron in them. That's because each orbital gets 1 electron. So the first p orbital, the second p orbital, the third p orbital, and then the 4th electron goes back in the first p orbital, sharing a bunk bed. The orbital diagram and the electron configuration on the bottom, 1s2, 2s2, 2p4, represent the same electron configuration here. There are 8 electrons total, so that's oxygen. It's also 4 over in the 2p, in the second row of the periodic table in the p block. So that's how we can figure this out. There are other videos that we can look at for more practice. That's our introduction to orbitals. Thanks for watching.